there may be something enormous lurking at the far edge of our solar system. So distant, so cold, and so faint that no telescope has ever seen it directly. And yet, for more than a century, astronomers have been quietly following its trail. They call it Planet 9. If it exists, it would not be a small, icy relic like Pluto. It would be a massive world, at least twice the size of Earth, and possibly several times more massive, moving through space on an orbit so vast that a single trip around the Sun could take 10 to 15,000 years. It would sit hundreds of times farther from the Sun than Earth does, tilted oddly compared to the rest of the planetary family, and largely invisible against the dark background of interstellar space. What makes this idea remarkable is not how strange it sounds, but how familiar the method behind it is. Planet 9 is not being hunted with cameras first. It is being hunted with math, how astronomers find what they can't see. The idea that unseen objects can reveal themselves through their gravitational effects is not new. In fact, one of the most important planets in our solar system was discovered this way. In 1781, William Herschel accidentally found Uranus while searching the night sky with a homemade telescope. For decades afterward, astronomers carefully tracked Uranus's motion and noticed something unsettling. The planet did not move exactly as Newton's laws predicted. At certain points, it appeared to speed up or slow down, as if tugged by something invisible. By the mid-1800s, two mathematicians, Urbain Le Verrier and John Couch Adams, independently calculated that another planet must be influencing Uranus from beyond. Their equations pointed to a precise region of the sky. When Johann Galle aimed a telescope at that location in 1846, he found Neptune almost immediately. This success permanently changed astronomy. Planets were no longer found only by chance. They could be predicted. A false trail and a hard lesson. After Neptune's discovery, astronomers noticed small irregularities in Neptune's own orbit. Once again, the hunt began for another hidden planet. That search culminated in 1930 with the discovery of Pluto. At first, Pluto seemed to fit the role perfectly. It was beyond Neptune, faint and slow-moving. But there was a problem. Pluto was far too small to influence Neptune's orbit in any meaningful way. The wobble that inspired the search turned out to be an observational error. This mistake revealed an important scientific trap: observational bias. When scientists expect to find something, they may interpret ambiguous data as confirmation. Pluto was not Planet 9, and yet the idea of another distant world refused to disappear. The Kuiper Belt changed everything. In the late 20th century, astronomers began uncovering a vast population of icy bodies beyond Neptune in a region now known as the Kuiper Belt. Pluto turned out to be just one member of a massive swarm of frozen debris, possibly containing thousands of Pluto-sized objects and billions of smaller bodies. This discovery reframed the entire outer solar system. It was no longer empty. It was crowded and dynamic. As more Kuiper Belt objects were cataloged, something strange emerged. Many of the most distant objects shared oddly similar, elongated, and tilted orbits. Some traveled far above and below the plane of the planets. Others moved in the opposite direction altogether. Random chance could not easily explain this pattern. The Planet 9 hypothesis. In 2016, two astronomers at Caltech, Mike Brown and Konstantin Batygin, proposed a bold explanation. A massive, unseen planet was shepherding these distant objects through gravity alone. Using large-scale computer simulations, they tested two scenarios. One solar system evolved without a ninth planet. The other included a distant, massive body on a long, tilted orbit. Only one scenario reproduced the strange alignments astronomers actually observe. According to their models, the odds that this clustering happened by accident are extremely small. The simulations suggest a confidence level approaching 99% that some large gravitational influence exists far beyond Neptune. That influence fits the profile of a planet. What kind of world would Planet 9 be? Planet 9 would not resemble the gas giants. It would likely be a dense mixture of rock, metal, and frozen volatiles. more like an overgrown Earth core wrapped in ice. Without a thick reflective atmosphere, it would absorb most of the sunlight that reaches it. Temperatures would plunge to extremes far colder than Pluto's. Sunlight would be little more than a bright star. If Pluto is a frozen relic, Planet 9 would be a cosmic deep freeze, geologically quiet, dark, and ancient. Despite its size, this planet would be extraordinarily difficult to detect. At distances up to 500 times farther from the Sun than Earth, even a large object reflects very little light back toward us. How did a planet end up so far away? One of the biggest puzzles is how such a massive world could exist so far from the Sun. There are two leading ideas. The first suggests Planet 9 formed closer to the Sun, perhaps between Saturn and Neptune, but was gravitationally scattered outward during the early chaos of planetary formation. It never gained enough mass to become a gas giant, yet was not flung entirely into interstellar space. Instead, it became stranded on the Sun's outermost gravitational boundary. The second possibility is even stranger. Planet 9 may be a rogue planet, a world ejected from another star system long ago and later captured by the Sun's gravity. Rogue planets are thought to be common in the galaxy, wandering through space after violent early interactions in their home systems. Either origin would explain why Planet 9 exists where it does, and why it seems so disconnected from the rest of the solar system. Could it be something else? As compelling as the evidence is, Planet 9 is still a hypothesis. Some researchers argue that the orbital clustering may be exaggerated by observational bias, since we are more likely to discover objects in certain regions of the sky. Others propose that gravity itself might behave differently at extreme distances, a possibility that would challenge centuries of physics. More exotic ideas have also surfaced, including the suggestion that the observed effects could be caused by a tiny primordial black hole left over from the early universe. While fascinating, this idea remains highly speculative and lacks direct supporting evidence. For now, Planet 9 remains the simplest explanation that fits the data: the telescope. That may settle the debate. The search for Planet 9 is about to enter a new phase. The Vera Rubin Observatory, which began operations in 2025, is the most advanced sky survey instrument ever built. Equipped with the largest digital camera in history, it scans the entire visible sky every few nights, building a time-lapse record of the universe over a decade. Instead of hunting for Planet 9 directly, astronomers will watch for motion, the slow drift of objects that reveal themselves only through change. If Planet 9 exists, it will move. And when it does, Rubin will see it. Why this matters? Planet 9 is not just another addition to the solar system. Its discovery would rewrite our understanding of how planetary systems form, migrate, and survive. It would confirm that the solar system is still full of surprises, and that even our cosmic backyard remains only partially explored. For centuries, humanity believed the solar system ended where the planets stopped shining. We now know that was an illusion created by distance, darkness, and limited tools. Somewhere far beyond Neptune, something massive may still be shaping the orbits of countless worlds. Silently, patiently, waiting to be found. And for the first time, we finally have the technology capable of proving whether it's real. Somewhere far beyond Neptune, something massive may still be shaping our solar system in total silence, pulling on distant worlds, bending orbits, and hiding in darkness for billions of years. Planet 9 might be real, or it might be the clue that forces us to rethink how gravity and space itself truly work. Either way, the story isn't over. With new telescopes watching the sky every few nights, we're closer than ever to catching the universe in the act. And when that discovery happens, it will change how we see our cosmic neighborhood forever. If you want to be smarter every day, like and subscribe.